Bismillahirrahmanirrahim. I am Professor Jamil and you are watching YouTube channel. Today we are going to take up a problem on Laplace transform which involves Dirac delta function, and this problem needs to be read very carefully. Only then you will be able to find the solution. So let's start. Show that this limit is equal to delta x. This delta x is the Dirac delta function, right? So you need to find the Laplace transform of this, then take the limit and prove that whatever you get, the answer is a Dirac delta function, right? Now, you know, Dirac delta function is defined in the form of an integral. Look, in this way. This is your answer, as Dirac delta function is a function such that when it is integrated for all values of x from minus infinity to plus infinity, then this is equal to 1. This is the definition of Dirac delta function, right? So this means you should integrate this equation with respect to x, right? You should integrate this equation with respect to x and check whether the answer on the left hand side is equal to 1 or not. So let's do this. So you may make an announcement as here is your answer to the solution as this. So let us integrate the equation given in the statement. So here you go. 1 over pi limit s approaches to infinity, Laplace transform of the cos of xt, and this is delta x, right? This is the given equation, and we need to integrate it with respect to x when x is from minus infinity to plus infinity, and the same thing on the right hand side. And this has been told by the defining property or definition of the Dirac delta function in equation 1. So you have written the integral sign on it. Now look, integration variable is x, so 1 over pi, and the variable s, they will be treated as constant and they should be taken out, right? And I am going to take it. 1 over pi and limit, they can be taken outside the integral sign, mean in front of the integral sign, because they do not depend on the variable of integration x. So x is from minus to plus infinity, and you have Laplace transform of dx, this dx into Laplace transform of cosine of xt, right? And the right hand side is same, no change in it. Okay, we can change it. We can substitute its value 1, and you can make this sign here, that this is an important step. This is 1 from equation 1. So this is, you can also mention using equation 1 on the right hand side. On the right hand side of this equation, or on the right hand side of this equation, mean this, you have used equation 1. Now look, here you need a function of x so that you can integrate. It means x should remain and t should vanish. You know, when you take the Laplace transform, then Laplace transform means a new function and a new variable. Old variable is gone. And here you should look very carefully. You need function of x, and when you will take the Laplace transform, then x should stay here. mean what? T should vanish. So T is the variable for which the Laplace transform will be written. And you know the Laplace transform of cosine function as Laplace transform of cos of kt is equal to, and it is equal to s over s square plus k square, where s is greater than k. And in place of k, you have your x, right? So when you write that, now you identify how to write the transform. And let's write the transform. It is 1 over pi limit s approaches to 0, x from minus to plus infinity, and dx into Laplace transform of this means this s, s over s square plus, in place of k you have x, so it is x square, and on the right hand side it is equal to 1. Okay, now this is an integral, and it is a standard integral, 1 over s square plus x square, which is 1 over s into tangent inverse x over a. So let's use it. Let's use it here on the other board. This, using this is the general form of the integral, a square plus x square, and this is equal to 1 over a tangent inverse x over a. And in place of it, this is your general standard formula which is written in the elementary calculus books. And when you use this relation here, look this, then in place of a you have s, and x is the same, and this s is a constant with respect to x, and it can be taken out. Okay, we get, okay, let's see what you get. 1 over pi limit s approaches to 0, this one, and s can be taken out, s, and integral is from minus to plus infinity dx into, this s has been moved in front of the integral sign, and you have here 1 over s square plus a square, 1 over s square plus s square plus x square, and on the right you have 1, this one. Okay, now using this you have 1 over pi limit s approaches to 0 in s into, this is 1 over s tangent inverse x over a, and x over a is for s. Look here, beneath the square is a, beneath the square is s, so this is s, right? And you need to apply the limit on x from minus infinity to plus infinity. On the right you have 1. Now this s can be taken out, and it is 1 over pi, our limit s approaches to 0, and s over s into tangent inverse x over s, and limit from minus to plus infinity. This s will cancel because s is not equal to 0. This limit s approaches to 0 means s is a number very much close to 0, but it is not equal to 0, right? It is for this reason that this s over s can be cancelled, otherwise it will not cancel. Okay, and on the right you have this one. Now 1 over pi limit s approaches to 0, and apply the limit, tangent inverse infinity over x minus tangent inverse minus infinity over s, and on the right is 1. Now 1 over pi limit s approaches to 0. Your s is a positive number. S is a positive number. It is fixed by the Laplace transform of the cosine function. S is greater than k, right? Okay. And k is what? Okay. Instead of going here, S, you have this condition. S approaches to 0. And your Laplace transform says that the 0 is, when you use the Laplace formula for the Laplace transform, then the limits of integration are from 0 to infinity. So your 0 is 0 positive. That means the S approaches to 0, and then S is equal to 0, or S is very much close to 0. Then that 0 is not a negative, it is always positive. Okay, and so you apply tangent inverse infinity minus, this minus sign will get out, tangent inverse infinity equal to 1, because S is greater than 0. This is fixed by this one. Fixed by this one. Okay. Now tangent inverse infinity is pi over 2, and let's write here 1 over pi into, okay, into limit s approaches to 0. Look, if s is negative, then this will become negative, and this negative will get cancelled, and it will become positive. So the things may change. Okay. Tangent inverse infinity is pi over 2, and plus tangent inverse infinity again pi over 2, and it is equal to 1. Right? Listen again, this is an important point. If s is a negative, then this negative would mean tangent inverse minus infinity. That will give you minus pi by 2, and this as a negative will cancel with this negative, and you will have tangent inverse infinity, that is pi by 2, and minus sign will remain intact. And this minus and the minus will make this minus pi by 2, and minus pi by 2 will make minus 1, which minus pi mean minus pi. That will create a problem. And the fact is, s here is not negative. If you are using the negative values of s, it will be your fault, because s is approaching to 0, and this is a transformed variable, right? And in the transformed variable, your uh, uh, your value of the variable from the original Laplace transforms, that starts from 0 onward, and similarly the transformed variable s will also start from 0 onward towards positive infinity. That means s is positive. So try to appreciate this point first. Okay, so s cannot be, listen again, used negative. It should be positive because of this limit. Okay, so 1 over pi, and there is no s, so there is no limit now. And look, the answer is an identity. It is an identity. It is an identity. Hence, it means what? Whatever is on left, that is equal to that on the right, as given in your original problem. This one, right? So you can restate the statement. Hence, 1 over pi limit s approaches to 0, and what is next? Laplace transform of cos of xt is equal to delta x, right? This is 1, this is 1, in a very special kind of way by using the definition of the Dirac delta function in the form of integral. Okay, so this is the final answer, and you may have noted that the solution was dictated by the problem itself, provided we had knowledge about the definition of the Dirac delta function. So keep watching for such more interesting questions, and please like, share and subscribe this channel with your friends and family, so that such exam questions and such strategical questions in which you learn how to solve the question, and how to solve the question is dictated by the statement of the question itself. To get this experience, please like, share and subscribe this channel. I am saying once again, thanks for watching.